Yes, thank you very much. This will be the last presentation for today, although thank you also for your patience. I can promise that I will stay in the time frame, so there's no danger. And of course, thank you very much for the invitation. It's always a pleasure for me to be again in South Korea. Thank you very much. The title of my presentation is Recent European Trends in Carbon Composites Technology for a Sustainable Future. Sustainable future is also the motto of this conference, and guess what? Also in Europe, this is a very important topic. But first of all, again, I would like to thank. This is right. Thank you. First of all, thank you for your visit to Germany recently in 2023. We met in Hanover, we met in Stade, and we met in Augsburg, and had a great time there. So thank you very much for being with us also in Germany. Yeah, the agenda, of course, I would like to explain a little bit about Composites United. What is that exactly? Then I would like to talk about sustainability goals of the United Nations, the so-called European Union Green Deal. Also a little bit about the German government lightweight technology strategy, the importance and contribution of composite materials to sustainability, and then a little vision I would like to share with you: fiber reinforced materials for carbon capture. The status of recycling of carbon fiber reinforced plastics is very important in this context, and then also summary, conclusions, and outlook. So first of all, a little bit about Composites United as a network. It has been formed out of the former CFK Valley in northern Germany, the Carbon Composites in southern Germany, and the leading edge cluster MyCarbon. Already at that time, but was before 2019, we had excellent relationship with Korea, with the city of Gumi and also Jeonju. And after January 1st, 2019, we are now Composites United. So this is one network, and the cluster MyCarbon is one part of this network. And together we are the world's largest network for fiber reinforced materials, which cover the entire value chain from the raw material to the reuse of the recycled materials. How is it organized? You see a map here of Germany, Switzerland, and Austria. So we have special regions. You see the north, the east, the west, and you see again MyCarbon, which is located, as the name already said, Munich, Augsburg, Ingolstadt, MyCarbon in southern Germany. We have a relatively regional structure, but the network itself is internationally positioned. There are some specific networks now about construction industry, because we think this is also a very future-oriented network, and there's some network also dealing with ceramic composites. We have a special research network where we are very active, and in total about 350 members. And the majority are small and medium-sized enterprises, then followed by research organizations. And this network, Composites United, is financed just by membership fees. And we do some projects, of course. Yeah, what is the portfolio? So what do we offer now our members? It's first of all technology, so that means driving know-how and technology. We generate and organize 50 plus, or have done that since 2012, 50 plus projects. Internationalization is very important, so that means creating market access. We have 2 international clusters in Austria and Switzerland, and we have 4 representatives also in Asia. The network itself, of course, is the core target. That means connecting composite people. And we have innovation days, special events with more than 3,000 participants. We have on a weekly basis web seminars that came up due to the pandemic, where we had no time to meet in person. There we had meanwhile more than 5,000 participants. Knowledge is important. We take care of education because young people are necessary. Market information, English and German course program. And in communication, that is our key task, of course. Sharing information, inspiration, we have newsletter, print media. When you have some time to visit our booth here, it is in B1 here at the end. There you can also get the newest magazine that we publish with newest results from our members. Yeah, now I come to the political part now, talking a little bit about United Nations, European Union, and also German government and the importance and contribution of composite materials. So when you look at the sustainability goals of the United Nations, that are in total 17 goals. And I think at least 6 of them are really directly related to composite material. So when you look on the right side to these 6 different goals, it is always important to have composite materials, otherwise it will not be possible to fulfill the goals. When we look now at the so-called European Green Deal, this is a target mainly the reduction of greenhouse gas emissions by at least 55% by 2030. And when we talk about these gases, it's mainly carbon dioxide, of course. And 70% of these greenhouse gases are produced based on the energy generation worldwide. So that means when we produce energy out of coal, gas, and out of oil, this is 70% already. So in order to fulfill these targets, it's important to look into the energy transformation. And it's mainly switching to wind energy, switching to a hydrogen technology, that means fuel cells. And when you do this, you see on the right side, the rotor blades in wind energy cannot be produced without composites. You have GFRP, you have CFRP, it's necessary. Also for the hydrogen storage tank, CFRP is the material of choice. So therefore, we can really see there will be no European Green Deal without composite material. The Composites United itself also advertises these ideas. We organize events. Here is one example in Brussels, where we say this event is called No European Green Deal Without Lightweight Design. You see on the right side a number of institutes, a number of organizations that support us. And maybe you wonder why here's the name lightweight design. The reason is that this goes back to the strategy of the German government. In Germany, lightweight design is a key technology, and they mean with lightweight design that all materials are covered. So that means wood, that means also steel, magnesia, aluminium. But of course, carbon composites have the highest lightweight potential. Lightweight strategy of the German Ministry of Economics has been developed first. And in this year, this strategy has now been transformed to a strategy of the German government. Composites United is also in the advisory board, and we worked together on this strategy and also on the transformation. So in Germany, it's very important to work on this lightweight technology. Now coming back to Europe, I said that we have done some advertising, some lobbying. In total, 3 proposed European Union initiatives are here. It's the European Green Deal, I mentioned already. It's a Europe fit for the digital age. So digitalization is really a big topic in Europe. Not all countries are on the same level as in many countries in Asia. And the third thing is an economy that works for people. And there's one bullet point now coming that means advanced materials for industrial leadership. So that means the advanced materials, the lightweight materials are covered in these programs. And this is, of course, also a success of the work we do. Now, how are advanced materials embedded in the European Union industrial policies? First of all, Critical Raw Materials Act. To secure the supply of materials is very important for Europe because we do not have all the raw materials on our continent. The second one is the Net Zero Industry Act, making Europe the home of clean tech. So that means innovation, scaling up of manufacturing capacity of net zero technologies to support the climate neutrality. And of course, resilience. Resilience is also very important for Europe. And finally, identify and assess the risk to economic security by European economic security strategy, to make sure that we have the raw materials, to make sure that we have the material in order to produce high quality parts. Now, what else is the European Union doing? They, of course, plan regulations, and the regulations go to circular economy for materials. That goes so far that they say that an automotive producer must only produce materials that can be seen in a circular economy. When they are not in a circular economy, you have to pay penalties. And this is, of course, not good for the European automotive industry. Therefore, we support, of course, that there are additional criteria when you select the material. That is the carbon footprint, ideal-wise carbon dioxide neutrality, and the circularity. In principle, it's good, but it would mean that you have the raw material, the manufacturing, the application, recovery, and you can all use the cycle. Nothing can be disposed. Keep the material in a loop for the same application. And this we found, of course, difficult. Carbon fibers, reinforced plastics look more like this today. You have the raw material, the manufacturing, application in use. You have some refurbishment. You do the recycling, which is mainly pyrolysis, starting with oil, so fossil sources. And on the right side, you have a big bin because there's also a lot of waste involved. The majority of the recycling processes focus on the carbon fiber because this is most expensive. The recycled or refurbished CFRP or also carbon fiber material is normally not used in the same application as the European Union regulation would like to see. On the other side, we think that the recycled materials have a value and can be used in other applications. So our goal is that we would like to reach an acceptance of circularity in cross-industry applications. That is very important. There's one example coming out of wind energy. You see a rotor blade. This rotor blade contains mainly out of glass fiber reinforced plastics, and they have some CFRP belts inside. And these belts can be cut off. They can be used at new parts. And it's only a mechanical treatment necessary here. And the parts are intact and can be used after testing, for example, in construction industry. And this is what we mean. We would like to see other circles in other application areas be filled and not always insisting on the same application area. So now I come to the already mentioned vision, fiber reinforced materials for carbon capture, and the status of recycling of carbon fiber reinforced plastics. So what does it mean? So fiber reinforced plastics are able to reduce carbon dioxide and be able to carbon dioxide sink. The idea behind this is that we look into research programs where we can produce fibers and matrix based on biogenic materials, so renewable fibers. The usage then in long-lasting product lifetimes, also important, and then we have a very effective processes for circular economy, basically in other applications. Here you see a nice overview on the regenerative carbon fiber production research activities that are going on at the moment. You see on the one side, on the top, you see the chemical approaches, where we go to lignocellulosic sugars, glycerol, methanol, and so on, up to carbon dioxide. And you see initiatives using cellulose, lignin, and rayon in order to produce carbon fibers. And the chemical ways are to produce acrylonitrile, polyacrylonitrile, and then you do the stabilization, the carbonization, and then the carbon fibers. So there's a clear trend in Europe also to go into the application by using renewables away from fossils. And that gave the idea that carbon fiber can even be produced out of carbon dioxide as a raw material, required basically, I'm personally a chemist, so I know these chemical methods. These necessary materials are air, water, and wind. So you need carbon dioxide, oxygen, and nitrogen from wind. The hydrogen is produced out of wind energy and electrolysis of water. And then you can use the carbon dioxide directly, or you can use it after the plants have taken it up as a biomass. And together with green hydrogen, you can easily produce chemicals. And methanol, for example, is a chemical, and this can be used in further steps to produce the green fibers or green plastics or other materials. These are all processes that the chemical industry has developed. Of course, the big hurdle is that these processes are not, from an economical point of view, don't make sense at the moment because they are too expensive. Yeah, then the next point for sustainability would be long-lasting material usage. And when we look at the usage of carbon fiber reinforced plastics materials, they are long-lasting. So that means in cars, 10 years, renewables, 20 years, in aircraft, even 30 years, bridges, 100 years and more, bicycles, sport and leisure, 10 years, and ships, maybe 20 years. So this is very different when you buy a plastic bag in a supermarket to carry your food home. This does not last very long, but in our application it lasts very long, and this is of course positive also for the carbon dioxide footprint. Now, how should, based on our vision, look the material flow of the future would look like? What is the circularity for CFRP parts? We start again with the raw material, with the fibers. We have now one additional step, which is the step designed for recycling. So when you want to build a material and produce a part, you have to think about how to separate this later. That is very important. You have the manufacturing, the application, refurbishment that is similar to before. We have a recycling process, pyrolysis and solvolysis or chemical. But the left side are regenerative sources, and on the right side, you don't have the waste bin. You have a final recovery, a new product life cycle. For this, it would be important that we have, of course, good recycling processes. Let me see, that was the wrong direction. So that means what is the status of recycling of CFRP? This is discussed very intensively. Basically, you have to balance between quality, environment, and cost. You have to think what is important. Can I really consider all the three parts? Does it make sense for me to do that? But basically, it does make sense because the material costs contribute by 42% to the cost structure in the manufacturing sector. And the material cost, when we have a CFRP part, it's basically the material itself is very important. And also the production of the carbon fiber, of the virgin carbon fiber, is very carbon dioxide intensive. So it makes sense to recycle this, of course, when it's economically worse. The reduction of cost, the environmental impact needs to be considered. And this could mean that basically at the end, there's also a higher attractiveness, especially for the automotive industry, which is a bit hesitating to using this material. So when we look, there's an interesting effect when we look at the demand for carbon fiber over the years. There's an increase, of course. You have, due to the pandemic, there's a slightly decrease. But it's interesting to see that the amount of waste is growing more than the demand. So there's really a need to do something with waste. Main drivers are aerospace, wind power, and construction. And this is a challenge, of course, but it's also a chance to do the right thing in recycling processes with this material, because there's also a big cost advantage. You see here the prices for virgin fibers, spool leftovers, waste weaving waste, and pyrolyzed carbon fibers. So the pyrolyzed recycled carbon fibers are low-priced material compared to the original ones. And there's another effect that also plays a role, which is the greenhouse potential. So when we were looking at some numbers about the carbon dioxide emission during the production process, the virgin fiber, there's a minimum, maximum. It depends a bit on the company that provides the data. That is relatively high. The recycled carbon fibers, here an estimation by Fraunhofer, are significantly lower. And the pyrolysis plant by Mitsubishi Chemicals running in Germany shows significantly lower numbers. So there are also further improvements expected in the direction of lower carbon dioxide emissions. Now, at the end, you have the recycled carbon fiber. That means what to do with that. Of course, in many cases, this material is new. It is not exactly the same properties as you had before. But you have a lot of advantages. You can have the orientation. Durability is good. 3D thickness is good. Fiber mixtures and types. Functionalization. Good stiffness. You have some minus points in the linear strength. But finally, it is very important to focus on the advantages of this material to be successful, and then, yeah, you will be successful. Now, basically, the recycling processes for CFRP can be divided in two parts. It's the mechanical processes, which is separation, fragmentation, and we have thermochemical processes, the thermal process, pyrolysis, gasification, or the chemical process, solvolysis. You have the use as a carbon source, reducing agent in metallurgy, or you can produce calcium carbide and use it as a carbide salt, or finally use as energy source. I will give examples about mechanical processes and thermal and chemical processes, so 3 examples. This is a very nice mechanical recycling of thermoplastic CFRP part, not thermoset. This is, has a big advantage. After these parts go through a shredder, you have chips, then it goes into a compounder, you have a granulate, and now you have an inject molding process where you can use an inlay, and out of this you get finally a new part. So here is a 100% reuse, and it's a mechanical process. When we look about the thermochemical processes, the thermal process that is common used and also commercially established is the pyrolysis. In the pyrolysis, the parts typically needs to be a little bit smaller. They go into a reactor. And then you have the gases. The gases can be, on the one side, used as chemical raw materials, or they can also be used as energy in order to just run the process. And the matrix in this system would function as the energy or raw material for chemical processes, and you would get back the carbon fibers. A nice another example for using a solvent comes basically from CATAC H from South Korea. The chemical cleavage of the matrix bonds, the recycling of the fibers and the matrix is possible, and the reuse of the solvent. And this is already established in South Korea. You see the step there. The scrap is collected, cutted, chopping, threading, peeling. You have the immersion, chemical reaction, washing, drying, processing. So that is a very nice example that you can recover both the matrix and the fibers. Yeah, what kind of products now making out of this material? There's a wide range of products and applications, especially when you think about other application areas. The cross-functional usage is here very important. Semi-finished products production by textile processes are possible to get an alignment. They have good mechanical properties, and in this case there is really an attractive price-performance ratio achievable. On the right side, you see some examples from Mitsubishi Advanced Chemicals. The challenges, of course, are standardization, which is required. The product availability, we talk about circularity, but there is basically not enough material in order to fill the circles. And you also need a certain acceptance of the market, because these materials are not cheap, they have a certain price, but the customers expect when they use recycled materials that is for free or very, very low in price. This is, of course, not possible. Yeah, then coming now to my summary, conclusion, and outlook. Carbon composites are an enabler for fulfilling sustainability goals of United Nations and the European Union Green Deal. Among all lightweight materials, especially carbon fiber reinforced plastics, show the highest potential for energy savings, for example, in the mobility sector. Challenges, of course, are the high price for automotive application, complex material, it's anisotropy and challenging processing methods, only eco-efficient with long-term use, but this is to be solved. The recycling processes are still in further development, they will be optimized. And the application of recycled carbon fibers would also lower many hurdles for use. In some cases significantly, because the greenhouse potential is high. And there's, as I said, when we use renewable materials as a raw material for the production of carbon fibers, there's even the chance that we have a carbon dioxide sink. And my outlook is now that, when you look at the sustainability goals of the United Nations, there's one, number 17. It is the cooperation, the partnership for the goals. And I think this is very important. We need international cooperation. This is a key for success. And you can see sports is a very good example. One of your famous players from Korea is now playing for Bayern München in Germany. He did a great job so far. All people are very happy with his performance. So this is something, work together in order to have together success. And this is the end of my presentation. Kamsahamnida. Thank you very much. And please ask questions when there are questions.
Minje is my favorite player.
He's a very good one. He's a very good, very strong, and a tall one.
Wow,
yes.
Yeah, he's a good defender.
Absolutely, yeah. One of the best in the world.
Yes, right.
Yeah, for sure.
Okay.
Thank you very much for your presentations. In your summary, I can see you mentioned like a high price for automotive field.
Yeah.
In Europe also, BMW using a lot of composite material in automotive area.
Yeah.
Also in Korea, a lot of activities. Yeah. But the cost is a problem.
Yeah.
Recently in China and Korea, the carbon fiber manufacturer expanding the capacities. So very recently the price is going down. Well, what do you think the price of carbon fiber, the carbon fiber composite, mostly the cost is from the carbon fiber itself. What do you think the future of the automotive area, the carbon composite, with this kind of circumstance, like cost down of carbon fiber, then do you think the spreading more applied for many parts of that in the car industries? So what do you think? Well, expectation.
This is a very good question. We are, of course, looking basically on the German car producers, like BMW, for example. They had a big effort made to use carbon fibers in their i3 production, for example. And they were now a bit stepping back and saying, okay, we have some parts in the 7 BMW, but not to that extent as before. They want to look more into recyclability of materials. So, and therefore, the carbon fiber reinforced plastics recycling is not really 100% solved. You cannot fulfill the circularity, and that makes the German car producers stepping back. So basically, they all left our organization because they do not see a future of CFRP in car and automotive production. That was a big surprise for us. I personally think that there's a chance when the prices go lower And you could not stop innovation in the automotive industry when you do not use certain parts. I see high potential using CFRP in automotive. Also from safety point of view, there are still not all possibilities used. So I personally think that there will be a kind of renaissance. So there will, of course, be at a certain point CFRP used to a higher extent. We know that in China this is very different. We know it also in train industry and bus industry. We have the trend using CFRP in Germany more in the truck and trailer industry. There we see that the 3.5 metric ton class needs to be lighter, and there the producers are willing to use CFRP, but the automotive industry in Germany especially is hesitating at the moment.
Yeah. Okay, does anybody have more questions? Okay, thank you, speaker again.
Yeah, thank you.